Hey everyone, and welcome to a deep dive into a part of your body you probably don't think too much about.
Well, until it causes us problems, right?
Exactly, but it's way more fascinating than most people realize. The human ear.
It really is. And today we'll be diving into some pretty amazing material about it.
We've got excerpts from Wikipedia, a whole scientific article on ear evolution, even a medical school resource.
We're going way beyond how we hear today.
Get ready to be surprised. We're about to uncover how much more is going on in there than just hearing.
I'm ready. Let's do it.
Okay, where to even begin? There's the outer ear, middle ear, inner ear.
Each with a totally different job to do. It's like evolution was working on a tiny scale, but acting like, a master engineer.
Optimizing for function, I like that.
Exactly. Our Wikipedia and McGovern Medical School sources lay it all out really well.
So the outer ear, that's the part we all see, right? Basically a funnel for sound, channels those sound waves right to the ear canal.
Which then hits the eardrum.
The eardrum, I remember learning it was surprisingly small. But just how W small are we talking?
About the size of a dime.
No way, seriously.
Yep. And here's the kicker. It's already fully grown at birth.
Wow. I had no idea it was that small, let alone fully developed right off the bat. That tiny thing is what's receiving all the sound we process.
It is. But it doesn't work alone, of course. That's where the middle ear comes in specifically, those three tiny bones.
Oh, right. I vaguely remember a diagram from school, but refresh my memory.
You got it. The malleus, infecus, and stapes. The McGovern resource calls them the hammer, anvil, and stirrup, which I think paints a pretty good picture.
Yeah, that's way easier to visualize.
And they're critical. They take the vibrations from the eardrum and transmit them to the inner ear.
So it's not just passing along vibrations. Are you saying they amplify them?
You got it. Amplify is exactly the right word.
Hold on, how MUCH are we talking here?
Those tiny bones amplify sound waves by 15 to 20 times.
Get out! 15, 20 times. I always thought the ear just kind of received sound passively. This is way more high-tech than I realized.
Oh, we're just getting started.
Yeah.
It gets even more wild once those amplified waves hit the inner ear.
Okay, bring on the wild.
All right, picture this. A spiral-shaped organ called the cochlea. It's filled with fluid, and here's the kicker. It's lined with thousands upon thousands of microscopic hairs. Our Wikipedia article gets into the details.
Okay, I remember the cochlea, but hairs, that seems a little too simple. Like, is it really hair in there?
Well, not exactly. It's a good way to visualize it. But those hairs are actually incredibly sensitive protein filaments. They're what make the whole system work.
Okay, so those filaments, those are what actually allow us to hear.
Precisely. When those amplified sound waves from the middle ear hit that fluid in the cochlea, these filaments vibrate, and that vibration gets translated into electrical signals.
And then our brain interprets those signals as sound.
You got it. That whole process, from capturing those initial waves to transforming them into something we perceive as happening constantly, is how we experience the world through sound.
That is unbelievable. From a whisper to, like, a jet engine roaring, all processed by this tiny, elegant system, way more complex than I ever imagined.
Right. And believe it or not, it's not just about hearing. This system is also vital for our sense of balance.
Right, balance. I always knew the ear played a role there, but never quite grasped how... Okay, let's break that down. So one structure, the ear, is doing double duty hearing A and D balance. How does that even work?
It's honestly a testament to evolution, It
Yeah.
finds these beautifully efficient solutions.
I'm all ears, no pun intended.
Well, the ear handles these two totally different jobs with two systems. Static and dynamic balance. The Wikipedia article explains it well.
Static versus dynamic. Okay, what's the difference?
Static balance is how you know where your body is compared to gravity. Like, are you upright, leaning, upside down, even with your eyes closed?
So if I'm just standing still, eyes closed, I don't topple over because of static balance.
Exactly. And it all comes down to these tiny parts of the inner ear, the utricle and saccule, inside. Microscopic calcium carbonate crystals. Otoliths, they're called.
Otoliths. Got it. Are those what actually sense balance?
Think of them like tiny grains of sand. Move your head, those otoliths shift like a snow globe. That triggers those amazing hair cells we talked about, sending signals to your brain. Hey, head's tilted this way.
So it's like a built-in level. Our ears are telling us which way is up.
Perfect analogy.
Huh.
Now, dynamic balance is about sensing acceleration, how fast, what direction you're moving in.
Okay, so that's why I don't get dizzy every time I turn my head or whatever. What part of the ear handles that?
Remember those three semicircular canals we mentioned?
Right.
Those are key. Each one's filled with fluid. Move your head, that fluid moves, and guess what?
More hair cells.
Bingo. They pick up that movement, send those signals to the brain, telling you how fast, which direction you're moving.
It's incredible how much those tiny hair cells do.
Right. And there's even more. This system is linked to our eye movement, too. That's why our vision stays stable even when we're running or walking. The inner ears helping coordinate it all.
Our ears, eyes, brain, all working together, it's mind-blowing.
The inner ear is like this tiny sensory powerhouse. And speaking of powerhouses, the story of how this whole system evolved is pretty mind-blowing, too. Our scientific article, Evolution of the Mammalian Ear, lays out this huge transition.
Oh, you mean the whole jawbones to ear bones thing? That blew my mind when I was reading about it.
It's wild, isn't it? The bones in our middle ear, those tiny amplifiers, the malleus and Titskas stapes, they evolved from the jaw bones of our reptilian ancestors.
So a structure for chewing turned into one for hearing. How is that even possible?
It was gradual, driven by changes in our ancestors' diet, how they lived, and natural selection doing its thing over millions of years. Bones that were involved in chewing got smaller, got repurposed for transmitting sound.
It makes you wonder how many tiny changes had to happen over how much time to get to this point.
And that transition, though it was likely about chewing at first, it had this huge impact on how hearing evolved. That's evolution for you, though, right? It's the ultimate tinkerer. Takes what's there, refines it, adapts it to something new.
Speaking of adapting, the article mentioned evolvability. What does that even mean?
So evolvability is kind of like, imagine a basic Lego set, right? A few brick types, you can build some things, but it's limited. Now imagine this massive set, tons of different bricks, special pieces, way more possibilities, yeah.
So the more complex the building blocks, the more potential there is for change, for adaptation.
Exactly. That's what happened with the mammalian ear. This complex structure, all its parts, how intricately it develops, it made it more adaptable to evolutionary pressure.
So we got bats using echolocation, whales communicating across oceans, and us, well, listening to this podcast.
Exactly. And it all traces back to this amazing evolutionary journey.
But as cool as all this is, this complex system isn't invincible, is it? What are some things that can go wrong with the ear?
That's a great point. Even with its incredible design, the ear is still vulnerable. One of the biggest challenges is hearing loss, which the Wikipedia article does a good job summarizing.
So hearing loss, it seems like there are so many ways those delicate hair cells can be damaged.
Absolutely. And once they're damaged, they don't really regenerate. That's what makes hearing loss so tricky.
So, like, what are the big culprits? What causes this kind of damage?
Well, there are actually different types of hearing loss. There's conductive hearing loss, which is often treatable, thankfully. That's where something's blocking the sound waves from getting to the inner ear. Could be earwax buildup, fluid in the middle ear, that sort of thing.
Oh, okay. So kind of like a clogged pipe, clear the blockage and things work again.
Exactly. But then there's sensorineural hearing loss. That one's more complex. It involves damage to those hair cells in the inner ear or even the auditory nerve itself.
And that's usually permanent.
Unfortunately, often, yes. And it can be caused by a lot of different things. Exposure to loud noise is a big one.
Concerts, construction sites.
So, all of that, yeah. Even listening to music on headphones too loud for too long. And then there's age-related hearing loss. As we get older, those hair cells naturally deteriorate.
So it's not just one thing, but kind of a combination of factors as we go through life makes you realize we really should protect our hearing. But what about people who already have hearing loss, especially the more permanent kind? What can be done?
Well, there are solutions, and it's pretty amazing how technology is stepping up to help. For mild to moderate hearing loss, hearing aids are common. They amplify those sound waves, making it easier for the ear to pick them up.
Makes sense. And then there are cochlear implants, right? Those seem pretty high-tech.
They are. Cochlear implants actually bypass the damaged parts of the inner ear and directly stimulate the auditory nerve with electrical signals.
Wow. So they're basically taking over the job of the damaged parts.
In a way, yes. It's not a perfect solution. It doesn't perfectly replicate natural hearing. But for people with severe to profound hearing loss, it can be truly life-changing. They can perceive sound, even speech again.
That's incredible. Are there other things that can affect the ear besides hearing loss?
Yeah, there are congenital ear abnormalities. Those are conditions people can be born with.
Anything from a slight difference in the outer ear shape to something more serious affecting the inner workings.
Exactly. And they can impact both hearing and balance, depending on what part of the ear is affected.
Which is why early detection is so important.
Couldn't agree more. It can make all the difference for a child's development, how they communicate and experience the world.
This whole conversation has been eye-opening. I never realized just how EPCH our ears do. They're not just about sound, but balance, our sense of space, even how our eyes move.
It really highlights how interconnected everything is in the body, right?
It does. Well, as we wrap up this deep dive, I want to leave our listeners with something to ponder. We've seen how evolution shaped the ear. But what about the future? Will we one day be able to regrow those hair cells, actually reverse hearing loss?
It's a question a lot of scientists are working on right now. And while there aren't easy answers yet, the research happening in gene editing, stem cell therapy, even artificial sensory organs, it's incredibly exciting. There's genuine hope that we'll find ways to repair or even replace these delicate parts of the ear.
A future where hearing loss doesn't have to be permanent. That's something to look forward to. Well, on that note, I want to thank you for taking this deep dive with me. It's been fascinating.
My pleasure. Always happy to talk about the ear.
And to all our listeners, thank you for joining us. We just scratched the surface of this amazing organ. There's a whole world of sound out there. Keep those ears curious, and we'll catch you next time.